Okay, so let's look at some of the setup and acquisition parameters that we can set on the PSM series power meters. This is currently a PSM 5000 series, but it'll be virtually the same for the 3000 and the 4000. The first thing that we looked at, of course, was to set whether it's in CW or pulse signal that you're measuring. That the frequency determines where it falls in the loss calibration table, which is a great benefit because you don't have to zero and calibrate. Let's take a look at some of these other features. Averaging, we default to actually 75 averages. I've actually set them to 1. But let's say we make this 2,000 averages. The way this averaging works is it takes a full 2,000 samples, takes the average and displays it on the screen. So you notice it goes a little bit slower than it was going before. If I take that averaging back down to 1, and I try extended averaging with the same 2,000 points, but now I enable this averaging, this is actually a boxcar average. So this is actually averaging each point as it accumulates until it hits 2,000, and then when it hits the 2001 point, it'll then average the most recent 2,000. So it's a rolling average. I'm going to go ahead and disable that. When you'll notice when that was activated, I do have a indicator X average, and I can reset that number if I choose to. We can also do a max hold. You now get a new indicator max, and whenever this thing is going to read another reading that is higher than what it is at, it will go ahead and update it. And of course you can reset the max hold and see where we're at right now, and you can turn it off. We can set limits. We can change the measuring units. I prefer dBm. Offsets is very important because, let's face it, we're typically putting these in automated test systems. We have cabling. If I have an error where I know that I'm losing, let's say, 3 dB in a cable, then I can enter 3 dB in here, enable this offset, and now it's going to compensate for that. It's going to add 3 dB to my measurement. If my offset is a little bit more complicated than that, and it's frequency dependent, so I measure my system before it goes to my power sensor, and I realize that I've got a loss per frequency, so there's a frequency response. I can then use the frequency response table, and I can go ahead and add in these different frequencies and losses, and therefore it'll then use this table of frequency response to do the compensation. We'll go ahead and disable that. The triggering menu, I've taken a quick peek at this earlier. We originally, and most of the time, you're going to be set to internal continuous, but this is also where you would set where you want to do an external trigger and you want it to be continuous, or if you want to do single acquisitions, internal, external, timeout triggers. For the trigger and the trigger out options, here is where you can enable them as well as invert them to go rising edge or falling edge. So very flexible trigger system as well. The sensor ID portion, when I click this button, what it does is it flashes the LED on the sensor 4 times. So if I have multiple sensors set up, I can figure out which sensor I'm actually looking at very quickly. The data logger option, there's going to be a separate video on how to set up the data logging, but I can stream all my measurements right into a file, which is really nice. And then over here we can save data and setups, and we can recall setups. And you'll notice the measurement menus up here are very similar to the ones down here. They're virtually identical with a few minor exceptions in the offsets and responses. You can, if you live in the 75 ohm world, you can actually offset for your min-loss pad automatically. If you're using an RMS power meter, the 3000 series, you can use the duty cycle feature to set up a duty cycle to give you your ballpark pulse measurement pulse power from that method. And you can also, if you want to just see the changes in your device, you can actually set a reference. And then your power meter is only going to read the delta between what you've set your reference for. down here. So nice flexible user interface for the PSM 3000, 4000, and 5000 USB power meters.